In section 4, I want to show you how to do Bayes' formula or Bayes' theorem without actually computing or knowing the formula. So we'll do the computations without the big formula. Bayes' formula is a way of finding the probability of an earlier event when we know something later happened. For example, in this problem, the company that makes widgets at two different plants, one in Texas and one in Georgia. Then they go on to sell some of these widgets later on after they're made, and then some of them are returned as defective. It says here the widgets produced in Texas, 5% are defective. Widgets produced in Georgia, 8% are defective. And so we make the widgets first, and then we know whether or not they're defective. And so the question, however, is if we know it's defective, what's the probability it was made in Texas? And so we're going to start by making us a tree diagram. Here's the tree diagram. In the beginning, the first choice is where it's made. Is it made in Texas or is it made in Georgia? It says 60% are made in Texas and 40% in Georgia. So we'll label the branches. T is 60 and G is 40%. That means in decimals. And then it's either defective or it's not. The ones in Texas are defective or not. Likewise, the ones in Georgia. Some are defective, some are not. We need to attach the numbers to these. So it says in Texas, 5% are defective. We put 5% on the D branch after the T. It says in Georgia, 8% are defective. So the D branch after the G gets an 8%. Now, we've done this before. We know that if this is 5, the other one has to be 95. So the branch marked D prime, not defective, would have to be 95. Likewise, if this one is 8%, the other one has to be 92%. Now it says if a widget is returned as defective. So let's find all of the branches that correspond to this statement. Which branches correspond to it being defective? That would be the ones that end in D. So we're going to take these branches, multiply out to the ends on both branches from the start to the end of the branch, multiply, add those up. This becomes the bottom number of our probability. To find the top number, we take the two branches that we have marked and find the one that corresponds to what we're looking for. The probability it was made in Texas. The branch that starts at the beginning and goes TD corresponds to the ones made in Texas. This branch we've already computed, multiplying out to the end, is 0.03. That's the top number of our probability. Dividing those two using our calculator, we get 0.45 or 45% probability that it was made in Texas if it was returned as defective. Here's a similar problem that I'll go through and show you again. The idea is construct a tree diagram. A medical test has been developed. The sample of people we know have 5% of them with the disease. Then we're going to give these people a test. The test indicates positive in 97% with the disease and 2% that do not have it. So our tree diagram starts with the people that either have the disease or don't. And we're told 5% of them do. Now, we're not told this, but we know the rest of them, as in the other 95%, don't. And then we administer the test. These that had the disease took the test. Some of them had a positive result, some of them had a negative. Same thing with the other ones. We're told in this sentence, the test indicates positive in 97% of those who have the disease. Here's the ones that have the disease. It shows positive in 97% of those. It goes on to say that the test also shows positive in 2% of those who do not have it. So these people who do not have the disease, the test still shows positive in 2%. Just like before, in the top one, if this is 97, the other one has to be 3. If this is 2, the other one has to be 98. So there's the proper tree diagram. And if the test is positive, tells us find the branches that end in a positive test. That would be the P's. Multiply out to the ends and add them together. That's the bottom number of the probability. Find the one of those branches that fits the description. Patient has the disease. That would be the one with the D in it. Multiply out to the end, which we've already done, and that's the top number. Dividing those two, we get 72% chance. So the idea is this test is given out to doctors' offices everywhere. They perform the test. It comes back positive. What do they tell the patient? Well, there's a 72% chance that you have the disease. Let's look at the other scenario. Here is the same problem, only this time we're wondering what to tell them if the test shows negative. And so we identify all the branches that end in N, multiply out to the ends, add them up. That's the bottom number. What is the probability they have the disease? The ones that have the disease out of the two branches that are marked would be these. Multiply out to the end, which we've already done, and we get 0.0015. Dividing those, we get a 0.1% chance. 0.1 means far less than 1%. That's such a small probability. We're pretty sure that if the test is negative, that they do not have the disease. However, if it's positive, we're not so sure that they do. That was 72%.